I am one of the resident team crazy people. I like playing with operating systems, hence why I got interested in virtual machines in the first place.
So who are you and what do you do? Why am I here?
I don't know why you're here. I'm Ben Armstrong, program manager on the virtual machine team.
Okay. And what does that mean?
Good question. Program manager is one of those job titles of
now we know what program manager.
100 different things.
Yeah.
So for me specifically, I do a lot of the management around. I talk to customers, get their feedback on virtual machines.
What is virtual machines?
Oh, virtual machines.
We've all seen program managers before.
Okay. So virtual machines are these things. Actually, I'll show you my non-secret desktop and say, so virtual machines is basically the technology that allows you to run multiple operating systems.
That music?
Yeah.
I hear music. That's
to run multiple operating systems on single computer at the same time. So as you can see, I have XP and Windows 98 running on the same physical machine there.
Wow. Okay.
Exciting.
Yay.
So and we have two products, Virtual PC and Virtual Server, the client and the server side of those.
So you work on those products?
I work on both. I actually was primary program manager for Virtual PC up there, and then after that I actually got to do the Japanese version of Virtual Server, which I thought was highly amusing because I don't read a word of Japanese.
Excellent.
So I have no idea what this box says. I hope it's all official.
I worked at a computer show in China one time, and I had to show off NetMeeting in a Microsoft booth, but it was Chinese version.
Yep.
So I had to memorize.
Right, all the buttons.
Yeah, that was a lot of fun. So, wow. So where do we go from here? So, how many OSs run on Windows Virtual?
So the good question is run. So we actually have an MVP site, which I quite like. So let me bring this up.
Okay.
vpc.visualwin.com. So this is a site that's run by one of our MVPs, Jonathan Maltz, if it loads, that basically allows people to come in and report what operating systems they've tried. It's not coming up.
So I would guess Windows 98 will run there.
So do you want to take a guess at how many operating systems have been reported to work under Virtual PC? This is
let's see. I'd guess 20.
So last time I checked, the number was somewhere around 600.
600? I didn't even know there was that many.
No, neither did I. So my wireless networking went down, so I'm going to have to plug it.
Well, I guess we did a Channel 9 video with somebody who had actually written 2 operating systems.
Yeah, so and the great thing about the site is it allows people to test like the obscure niche ones. So obviously like all the mainstream ones, like all the Windows flavors, DOS, Linux, FreeBSD, they all run. A lot of the stuff on the Visual Win site is going over, Beernix 1.0 beta. Yes, it runs. I mean, really, from the virtual machine team point of view, our approach has always been to create an authentic virtual machine that could run anything. Now, obviously, we don't have time to test every single operating system out there, and there are bugs, and some operating systems don't run. But more of them do run than don't. So I think I'm still trying to bring this.
So you probably, out of everybody at Microsoft, you know more about operating systems than most other employees.
Well, we have a very different perspective on it. It's actually quite interesting when we're talking with other teams, because other teams think of operating systems, they think of Windows, they think of it coming from the top down. They think of they're coming from top level APIs calling into Windows and getting the lower levels of Windows to do stuff for them. Right. Whereas we quite often see things from the bottom up. Our view of Windows is what it does with the CPU and what it does with the memory, and so on and so on. So it's a very different perspective, and it's interesting. So
what's your favorite operating system?
That is a tough call. One of my obscure pieces of history, which I can say on this team, is I actually started out as an OS2 developer.
Oh, wow.
And I first got interested in Virtual PC from Connectix because it could run OS2.
Were you working at Microsoft at that time?
No. No, I actually originally was working in Australia for State University. I came across and worked for Connectix, and when the Connectix technology was acquired by Microsoft, I came across with that.
Wow.
So I've just got this site up and running. So this is the VPC.visual site. And if you show, I've just selected to show, does it work? So we have 656 operating systems that have been reported as working under virtual PC, and they're all listed here.
Wow.
So as for my favorite one, I don't know. I've always been a strong believer of like, every operating system is good for something.
Right.
There's no operating system that's so badly designed that it doesn't have one area where it's good. So, you know, DOS is a great operating system if you just want to run one program and completely monopolize the system. DOS is great. So probably the ones that I spend a lot of time playing with, I play with DOS a fair bit. I play with OS2 more for the nostalgia. I have all my old OS2 stuff set up inside of Virtual PC.
Wow.
And I play with BOS a lot, simply because it's incredibly hard to get running well inside of a virtual machine. So I like bringing it up to say, hey, look, it runs. So
can you actually run BOS on Virtual PC?
Yes, I'll actually just bring up a couple while we're sitting here. I'll put this away.
And how much RAM do you really need to run Virtual PC?
You can never have enough RAM.
Can you repeat that again?
Yeah, the more RAM, the better. So this is my faithful laptop. It's a 2 gig P4 mobile with 1 gig of RAM.
1 gig of RAM.
My home system is a dual Opteron with 2 gig of RAM.
Okay.
And I'll probably be upgrading it to 4 gigs soon, because you can never have enough RAM when it comes to running virtual machines. Okay. So you can see here, this is my...
Why do VPCs take so much RAM?
Well, I mean, the issue is that every time you start a virtual machine, you have to allocate enough memory to run the entire operating system. So normally you would only have enough memory in your computer to run one operating system. Whereas with virtual machines, you're now running, 3, 4, 5, 6 operating systems. And you basically need to multiply your RAM requirements in order to do that. So for instance, running Windows 98, you'll need to have 128 meg dedicated RAM to run that.
Right.
So, and the more you want to run, I mean, obviously if you're only running one at a time, you don't need that much RAM, but it's the sort of technology that once you get used to it, you get used to being able to run 4 operating systems at the same time and switch between them and so on. So,
right. Do you guys do anything to make competitive operating systems run slower?
No. However,
how can we be sure?
I will catch this. It's actually a common question that comes up, and the first thing to say is, we create a virtual machine, and that includes like a virtual motherboard, the processor, the video card, the so on, and there is no magic like, third-party instruction. Like there's no like secret CPU operation that only FreeBSD uses that you could go, well, we'll turn that off and that'll stop that from working, because if you modify the architecture, you'll stop Windows from working as well.
Right.
And so that's why we've always had the mentality of building a very complete, authentic system.
Okay.
Now, having said that, we have a list of supported operating systems, which is much more in the 20 operating systems ballpark. And those are the ones that we test thoroughly on. And there may be bugs in our device emulation that you'll hit on unsupported platforms that we don't know, and it's like, yeah, well, that's an unsupported platform, we didn't test on it.
You still can't emulate video cards very well, right?
Well, we can, and that's a problem, because people don't want us to emulate video cards. So the
NVIDIAs and the ATIs don't want you to...
Just to try and clarify the difference here between emulate and virtualize. Okay. What people want is they want us to virtualize the video card. Because virtualization is where you take whatever is physically there and just make another copy of it. Okay, so we virtualize the processor. If you're running on a P4, your virtual machine has a P4 inside it. If you're running on an Athlon, your virtual machine has an Athlon inside it. However, we emulate the video card. So what that means is no matter what video card you have in your physical machine, you'll have an S3 Trio inside of the virtual machine. And that's the subtle difference there that a lot of people miss.
Okay.
We do virtual machines with emulated devices. And what people do want is virtualized devices. That is a lot harder.
Yeah. So if I ran Flight Simulator, for instance, in native mode, it would get 30 frames a second or whatnot. What's the experience like when I run it in the virtual machine?
So the biggest gotcha with the virtual machine is we have the emulated video card, as I mentioned, and it's only 2D capable.
Okay.
Having said that, it's actually quite fast for a 2D card. We chose a card that's very simple to implement, so it's quite fast for a 2D card. And I'm a gaming person, and I use Virtual PC to play a lot of legacy games that will only run on 98 or DOS or so on, and they're quite playable. I think I can't remember the exact details, but running Quake 2 with the software renderer on my laptop, I can get like 200 frames per second on the benchmark test.
Okay.
So
that's really cool. So you got B05 there?
Yeah, this is BOS Max, which is a version of BOS 5 up and running. My favorite thing to do under BOS is to run the little demo that does the GLT ball. Riveting stuff.
And so that's running in Virtual PC?
Yep, this is running in Virtual PC, and as you can see at the same time I have OS2 running here. This is actually my old development environment that I worked on in '98. I believe was the last time that I actively worked on it, and I stuck it in a virtual machine and it's been there ever since. So.
And you got Linux running somewhere too?
I don't know if I have a Linux VM handy.
Okay.
Actually, I do. It'll take me a moment to boot up. I have a SUSE 9.1 VM, which I'd have to say, of all the Linux distributions today, SUSE is my favorite one.
Interesting.
I used to be a Red Hat person, but no, I like Red Hat seems to have not been pushing the boundary for usability that SUSE has. Just my personal preference.
Cool.
So.
This is how I play with my OSs.
I mean, it's great. As I mentioned, I got interested in Connectix to start with because they ran OS2. Before I started working at Connectix, I had a home setup with about 4 physical computers and about 8 different operating systems that I play with. And it was really frustrating because every time I wanted to try and install a new operating system, I invariably had to blow away an old one, and I had to decide which one I didn't care about. And then you'd have these complex, dual, triple boot systems where you'd do something in one and it would upset the others and so on. And that's where I absolutely love Virtual PC because it allows you to just go out, grab an operating system, and have a play with it and see what happens.
Yeah. So this is SUSE. This is Linux here.
Yep.
Interesting. Now, how come you can't emulate the Macintosh on PC?
So this
the reason I'm here, right, with the Macintosh version, the team down in Silicon Valley said I should come and talk to you guys.
So this comes back to the whole virtualization versus emulation.
Okay.
So what Virtual PC for Mac actually does is they emulate a PC on top of a Mac.
Okay.
And what they do is they emulate the x86 architecture running on top of PowerPC.
Okay.
Whereas what Virtual PC, so strictly speaking, they shouldn't be called Virtual PC, but that's a longer story.
All right.
Whereas Virtual PC for Windows actually virtualizes the underlying architecture.
Got it.
And it's by doing that that you get a great performance boost, but it also means you're stuck with an x86 architecture.
Okay.
If you wanted to do Mac on PC, you would actually have to emulate a PowerPC architecture on the x86 architecture.
Right. And probably Steve Jobs wouldn't like that, would he?
I'm fairly certain that he wouldn't.
Yeah. If I ran Linux on the Mac and Linux on the Virtual PC version, because it's virtualized, you would see better performance here? Is that
Definitely.
what you're trying
Definitely.
to say? Okay.
I mean, having said that, Linux isn't officially supported.
Right.
So we don't spend as much time doing performance tuning and so on Linux as we do on Windows. However, the performance of Linux under Virtual PC for Windows is definitely better than Virtual PC for Mac because we have the native processor there. We can use it directly.
Right. Now, what advantage does having virtual PC mean for developers? So you're a developer too, right?
Yep. Well,
It means you
not
can-
on the product. I
Right,
do
but
my
you
own
can-
development.
I've seen developers who use it a lot, both internally and externally, to do testing, right?
Yep.
So you can test, on 5 different OSs, from one machine without having to, load up another hard drive
Yep.
or anything.
I mean,
the way we had to do it in the old days.
There's firstly like the pure consolidation play, which is kind of what you were talking about, which rather than having 5 machines sitting around, you can have them there, and rather than having one machine which you constantly re-image, you can have them all sitting around. One of the other great things for development, and this is actually one of my favorite demos. I'll pause this Linux box in the background because otherwise I'll be running short on space. Actually, I think this is going to complain that I don't have enough memory. No, it's not. Good.
We'll talk to your boss about that.
You
get another gig of RAM.
I think for over a year now, I've been saying I need LCD panels rather than CRTs, and it's not going.
My boss doesn't listen to me either. Actually, that's not true. But I had to go to the tablet team to get a tablet, a new tablet, which I greatly appreciate.
Actually, I'm going to save state this Linux machine because
That's a good question. If I ran the tablet OS on this, would it support Inky?
I don't know.
All right.
It's kind of hard to say. It might do.
Okay.
We have virtual machine editions, which when you install, they give you integrated maps. Okay. And if you did that, it might support inking. I'm not 100% certain.
All right.
I know we support tablet as an operating system that you can run virtual PC on top of,
okay.
But we've never really done much work looking into if you ran tablet inside of virtual PC, whether it would work.
Okay. I'll have to try that.
My laptop is melting down at the moment.
Ah, that's fine. You were running like 8 OS or something.
Yeah, this is what happens, and the usual trick is to stop Outlook.
Oh, that is guaranteed. That guarantees we're going to run this video. Go and talk to Steven Sinofsky about that one. All right, hold on.
Back?
Yeah, so we're back.
Okay. So a classic example of strength of virtual machines for developers, and this is one of my favorite demos to do. So I have my Windows 98 virtual machine here. It's up, it's running, everything's happy. I'm going to shut it down and restart it in MS-DOS mode. Okay. So we'll just give that a moment. What I'm going to display is one of the great features for developers is we have what's called undo disks, where you can go ahead and make a bunch of changes to a virtual machine and then undo them and go back to a clean state.
Okay.
So we'll just wait. So now we're at the DOS prompt. I'm going to start up everyone's favorite program, fdisk, and I'm going to say, let's delete my primary partition. No label, go ahead. So now if I exit and reboot, we'll see that it's no longer able to boot because I've just deleted the partition. Just here we are going through BIOS. And it's going, hey, you have no partition. Now, if I was having second thoughts about fdisking my system and going, maybe I didn't want to do that, it's trivial to say, turn off and delete those changes. Those changes go away. Now when I start up the virtual machine, it's able to come up and it'll boot Windows 98.
Oh, that's cool.
Completely unaffected. And so that's great for developers because, you're developing something, you're testing it, you're like, if you do something wrong, it might, completely hose the entire system. Yeah. And virtual PC allows you to throw it in that virtual environment, run it, see what happens, and then just roll back to a clean slate.
Wow.
Which is very powerful.
Yeah, that's really neat stuff. That's a lot better than trying to do your testing in a native.
Yeah, and I mean having to re-image it and so on, and wondering, hey, running on a clean environment, or maybe it just works because of stuff that's left over from previous tests that I've run, so on and so on.
Right. Anything else that's cool about virtual PC? Maybe show an MVP or a developer, or any tricks or any.
I should probably bring up my Bob image, because that is the one that I get the most hit on. I actually the first thing I did when I came to Microsoft was hit the product archives and look for a copy of Microsoft Bob to install, because it was one of the few operating systems that I hadn't been able to find a copy of while I was working at Connectix, because it's always been a hobby of mine to find obscure operating systems, throw them in a virtual machine, and have a look at them. And I couldn't find a copy of Bob, but as soon as I came to Microsoft, first thing I did, find a copy and get it running. So here we are. In a second, we'll see the lovely Bob smiley face come up. So there you are.
Awesome.
So I'm going to cancel my backup.
And there's the Clippy dog.
Yep.
Yep.
So I'll actually, wait a second, I actually posted to my blog saying, hey, look, Microsoft Bob runs. And someone came back to me and asked me to check into something. And this just shows you how far both we as Microsoft and the computer industry as a whole has come in regards to security. So here's Bob, okay? Yep. It's the home user environment. So I'm going to say I want to set up a new account. So I'm going to say, yes, I'm new. Next, so it's going to ask for a name. Dan, I prefer to put Dan. I think it requires me to put some food. No. So it gets me to set up a password. So I type in my password. I'm going to skip over that. And now it goes ahead and sets up my user account.
Yep.
So now that I've set up, it sets me in. I now have my private Bob account where I can do stuff. Now the hilarious thing is if let's get out of here. If I exit, and it'll take me back to the front door where I need to knock. Bob walks out. Bob walks in. So knock, and I say, okay, I'm Ben. So it asks for my password.
Yep.
So I type in the wrong password. It says, that's the wrong password. Do you want to try again? So I type in the wrong password again.
Yep.
So the third time I type in the wrong password, it says, have you forgotten your password? And I say, yes. And it blanks my password and allows me to set a new arbitrary password for it. So that was security in Microsoft Bob.
Wow. What kind of skills do you need to work on this team?
As a developer, or a tester, or a PM?
Any of the three, yeah?
It ranges a lot. We have developers, testers, and PMs at all different levels. I mean, we have developers who solely work on the emulated devices. And the emulated devices are actually written mostly in C code, but a lot of that is like looking at the device spec and figuring out what's appropriate, and just implementing that through emulation. We then have like the virtualization side of it. That's where you get a lot lower level OS, like kernel level development. And we also have developers who obviously work on things like the UI and the basic end user stuff. So we really have the whole range of developers. And similarly for testers and PMs. On the test side, there's from some of the really cool stuff that I love seeing out the test team is we have people writing tools which will like automatically install an operating system inside of a virtual machine without any user interaction. It just goes through it, like looks at all the screenshots, figures out what needs to be typed. But so there's a single script that you run, it creates a new virtual machine, installs an arbitrary operating system, and tells you whether it succeeded or not. And we have from that all the way through to like people who are writing custom tools that will go in and hammer our emulated hardware and our virtual processor and do things that a normal operating system normally wouldn't do. Yeah. So that we can know whether it works or not.
So you're hiring on?
We're currently hiring on all positions.
Okay.
So if you're interested, feel free to go to Microsoft.com, look for available positions. But yeah.
Interesting.
You have a mail.
A mail. Oh, that's cool. Well, thanks for showing us around. I mean, this is there anything else you wanted to show us?
No.
Yeah. This is pretty cool stuff. I think it gives us a good sense of what your team does and the challenges they're in. What's been the toughest OS for the team to get to work?
The toughest OS. So I guess this will actually give me...
Probably Longhorn, right?
Well, so firstly, it's actually kind of interesting because we have a number of people on our team who have done what we refer to as virtual machine bring up multiple times. And this is kind of the process for starting from scratch with a virtual machine that can't do anything. And there's kind of this logical progression of things you do. So the first thing that you want to do is you get DOS running. DOS runs entirely in real mode, and you get it up, you want to get through the BIOS into DOS, and then you're great. And so the progression usually goes, as soon as we get DOS running, the next thing you want to do is you actually want to get Doom running.
Interesting.
Because Doom is a game that runs entirely in real mode, but it exercises a lot of the emulated devices. It exercises the video card, the hard drive, the sound card, so on. If you can get Doom running, that's a good step. The next one you want to get running is actually Quake, because it's a DOS game that runs protected, and it also makes heavy use of the FPU. So that's a good test. So after you've got Doom and Quake, next we move on to like looking at Windows 95, Windows 2000, those sort of operating systems. And then we kind of expand out. And there's no one operating system which I'd say like, gee, that's the hardest. There have definitely been some which have been like, wow, like I would never have picked that. A classic one would be getting OS2 running inside of a virtual machine. It does a lot of things which, architecturally speaking, other platforms don't do. Windows, for instance, runs all its code in Ring 0 and Ring 3, and that's a fairly standard approach. Linux does the same thing. OS2 actually uses Ring 0, 1, 2, and 3.
Oh, wow.
It doesn't do much in Ring 1 and 2, but it does use them. And so that can make life a lot more complicated. In regards to things like, you mentioned Longhorn, that really comes down to device emulation. And that's like, it's a challenge that you have to deal with, but it's not the hardest thing.
Right.
The hardest operating systems to deal with are definitely the ones which make use of like weird aspects of the x86 architecture.
Can you give us an example?
Another one would be BOS.
Okay.
BOS, very hard to get running inside a virtual machine. One of the reasons is BOS uses an aperiodic timer, and it makes a lot of assumptions about how quickly the physical machine will be able to return on a timer and return on an interrupt. And those assumptions don't always hold true inside of a virtual machine. So there are things like that that make it very hard to get up and running. It's one of the reasons why I love the fact that BOS runs well today is I used to bug the CTO at Connectix, who's now my director, about the fact that BOS didn't work. And at one stage at Connectix, I got him to say, BOS will never run inside of a virtual machine.
Interesting.
And we got it to run.
Interesting.
So I'm like, look, it works.
If Dave Cutler or somebody of that ilk, a kernel developer or designer, architect, God, if you want to call him, walked in here, what would you ask him? What would the conversation be like?
If Dave Cutler walked in here, I'd probably hide under the table. That's a tough question.
Yeah. Because you've gotten a mind into how they think, or a look into how they think, in a way that most of the geeks here have never really looked at it.
And I mean, we do talk with Dave.
Yeah.
And architects on my team go and talk with him. And there is quite often this interesting conflict of what happens and things that architecturally make complete sense from a hardware point of view. And Dave's very much about making sure the system's solid, performant, reliable, so on. And his thinking of it, and we're sitting here going, well, in a virtual machine you should do this. And it's like, no, that doesn't apply to hardware. And so there's this conflict, but it's a good conflict. Okay. So a classic example, just to I'll avoid drawing the lame diagram. An interesting situation we hit upon is Windows, especially Windows Server 2003, implements what's called a memory stride, where what this is as it goes through the physical memory and touches pages in memory, it actually skips pages. And it does it, and that's the stride, as it were. And it does that in order to get optimal performance on a physical computer, so that as it's touching the memory, it actually touches it in an appropriate order. However, in a virtual machine, our memory can be arbitrarily mapped to any physical memory. So doing any stride calculation whatsoever is completely wasted effort, because you don't actually know what physical memory you're being mapped to at the end of the day.
Got it.
So that's the sort of things that we quite often talk with like the architectural team on Windows about, and trying to figure out what's the best way so that we can do the right thing for both virtual machines and physical machines.
Wow. Lots of fun.
Yeah.
Any other weird things that you'd like to tell us about working on a virtual PC team? I mean, any stories or?
I'm the person who keeps the beer.
Friday afternoons,
Yeah,
this is the place to be, yeah?
This is the stash.
All right.
There's my fridge.
Oh, wow.
It's full of
Do you have
beers.
VPCs in there?
No, it's full of beers.
Cool. Well, that's cool. Thanks.
Yeah, no
It
problem.
was fun.